Welcome everyone. We can probably just get started. I get in the habit of awkward Fs where we wait like 3 minutes, but this is a small enough group. Wow, a lot of new people. Let me just scan the names quick. Why don't we just start with the overview of where the people working on sequencer stuff have gotten. Remco/Carl, whichever you'd like to go there. Kev.
Sure, I could take it. So we've been making good progress on the sequencer. We have a test instance up and running, and we're kind of implementing the final things. I guess from my side, the biggest missing thing is the entropy generation. Well, actually, no, this is client-side stuff from the library. The sequencer should be mostly done. We're still doing a BLST backend implementation, so we can easily switch between using ArcWorks as a backend and BLST, and then decide whichever we want to use in the production version, or maybe even run both of them in parallel.
Okay, so yeah, that sounds pretty good. Any other people doing sequencer work have an update or some other context they'd like to add?
So I think one important information is I've updated endpoint documentation in sequencer specs, but we still haven't finalized all of the fields that are coming in the request and response bodies. So if you're doing client work and want to interface with sequencer, you should probably use the version that's deployed to Fly.io to make sure that the data that you're getting makes sense.
Okay, great.
I just have a comment there. On the front end part, we are integrating it and everything's going good. The only thing that we were having some issues with the deployed version was the redirect. We need you guys from the backend to authorize us on the domain to redirect, right? Did I express myself correctly?
Yeah, I think this makes sense. The redirect might actually be defaulted to localhost, where it should be now also allowing the Fly.io redirect.
I was responding about that on Telegram yesterday. So the redirect URL doesn't really matter because the front end can make it whatever they want. But Remco, you need to whitelist them in the applications you have configured. So the application that you are running on GitHub and the one inside ethereum.org, you need to whitelist all the URLs that the front ends will be using.
Yeah, isn't this problematic because this makes it closed? Can we instead just whitelist the sequencer and then have the sequencer do another redirect to whatever the front end wants?
We could do that. I was proposing that a few weeks back, and then Kev suggested we skip it for now, but we can get back to this.
Okay.
Wait, I don't think that's a part of any of the OAuth flows.
I mean, you can just wrap the OAuth flow so that it's easier for the front ends to use, because if you want to be truly decentralized, you probably want to have independent front ends without needing to whitelist each of them.
No, I mean, like there's like specific OAuth standard flows, and I don't think that's one of them. If you want to do like arbitrary front ends, it's either whitelisting them or you have to have the people run the front end on their local host.
No, this is correct, and this is why we need to why we need to have an additional redirect outside of OAuth to circumvent this OAuth limitation.
Yeah, we can do that in app. So we get the callback from the OAuth provider to the app, and then our app responds with a redirect to the front end.
Wait, how? I don't understand how you do that, because the redirect needs to redirect back to like my client, but everything is stateless, right?
Okay, I try to prepare a proof of concept today and then let you know if it works. I have a good feeling about it. It should work.
I'd probably suggest to look at the OAuth standard flows that they have, because they have like a lot of standards and they sort of made things the way that it is. So I don't know about security if we're doing something outside of the standard.
I want to plug in after OAuth. Like OAuth is already done and then I'm redirecting.
Exactly. This does not impact OAuth at all.
Okay, maybe I need to look at the document.
Yeah, I think the main risk here is that you will be transferring the bearer token that you got from GitHub or Ethereum. So this is something to consider.
Sorry, I didn't get that. You'd be transferring the.
So once you sign in with GitHub, you receive a secret token, right? And by
Right.
default, it goes to the front-end app. But
Yeah.
now what Martin is suggesting is that it would go to sequencer, and then that sequencer would forward that secret token back to the front end that initiated the call.
No, the sequencer can redirect with the session ID already. So I can exchange the code for the token, and then I can remember the token in the backend, generate a session ID in the backend, and then redirect to the front end passing the session ID parameters.
Yeah, that makes sense.
Yeah, maybe I need to see the document. I'm not fully grokking how it works with OAuth.
I'll try to build a proof of concept today or tomorrow, and then let you guys know in Telegram if it works, and then you can take a look if you find it insecure in any way.
All right, thank you. Yeah, on my end, I was trying to test out the endpoints. I couldn't get the fly.io version working. I think I was getting an invalid CRF token. So I was doing it offline instead. I did, just to make sure everything was interoperable, I used the cryptography library that the sequencer was using, and it seemed to be slow on the CLI. I think from what I was using, I was doing add entropy, which is doing validation checks before the contributor added the entropy. So I think there were sanity checks. Some of them are not in the spec, like ensuring that all of the SRSs are unique. And there's another comment to say that the public keys need to be distinct. I think some of these checks we did say we were not going to include. And I think most of the checks anyways should be done after the contribution is done. I think Carl may have made that optional in the specs, if I remember correctly.
Yeah, I mean, just one sec there, Kev. It sounds like you're talking about two things, because those checks should never be performed on the front end anyway. Like if you're being passed a contribution file, you don't have the information to do uniqueness checks. Because you don't have the full transcript.
You do have some uniqueness checks you can do. For example, unless you're the very first contributor, all the points should be distinct. Otherwise, you're in some small order subgroup, which you want to avoid.
All the points should be distinct unless you're in a small order subgroup. Why? I mean, I agree all the points should be distinct, but that to me, the subgroup checks cover the subgroup thing independently.
This is not a subgroup thing. This is a, let's say I make tau a root of unity of order, let's say 256. Then you get like a repeating pattern every 256.
Okay.
Great. So my question towards this is, aren't all of these things covered via the subgroup checks and the structure checks that we do?
They are not. These are additional checks that are relatively cheap to do, that do prevent some failure modes that are not otherwise covered.
So
Sorry,
what is
who
the
should do
failure
these
mode here?
checks and why?
I mean, this is just going the extra mile, and we can remove it if you don't consider it necessary or otherwise dangerous. But what I'm doing is I'm just taking the raw binary encoding of all the points, and I just make sure that all of them are distinct. And what this, for example, covers that is not otherwise covered is that if tau ends up being, let's say, some root of unity of small order, that would pass all the other checks, but it would result in a repeating sequence of values in your ceremony instead of distinct values.
Well, only if all the participants do it.
Yeah.
Correct. And like I said, it's not particularly important to do this. But
I mean, any participant who, like, I mean, there are many ways in which I can add no entropy, right? I can do it by just setting my secret equals 1. I can do it by setting it equal to a root of unity.
Yes.
Or I can do it by choosing it randomly by publishing it. And which one of these is it? It is, doesn't matter at all. So the only thing you're protecting is against possible implementation faults that generate a root of unity, which seems, I don't know, very unlikely.
I agree. That's just why.
Like, we are not protecting against dishonest participants, because dishonest participants have other ways in being dishonest. I don't care about that.
I agree. These checks are not there to guard against any particularly sophisticated attack. They're more sanity checks that guard against stupid mistakes, so to say, or implementation.
Well, also,
errors
just to be clear, this only helps the very first participant, because after that, even if someone chooses root of unity, their group elements will still be different.
I mean, you could do something. You could have two participants colluding, and like one multiplies by a random factor and the other multiplies by the inverse. There are tricks around that, but you know,
right.
it's getting.
But I mean, as soon as
it's getting into extreme scenarios.
As soon as you have had one properly random contribution, you agree that it should be impossible to make it a repeating sequence after that.
I agree.
Okay.
If this is something
So
we're worried about,
it seems very low value in my opinion.
If this is something we're worried about, I think we should check it on the sequencer side.
Sure.
Well, actually, no. I think the sequencer it adds absolutely nothing for the sequencer here.
No, you could still be the first honest participant and basically leak some information there.
How?
Like if
you use a root of unity, then you are not an honest participant.
So the people in front of you use roots of unity, and then you add on the first valid contribution on top of that.
Mm-hmm. That doesn't matter. That doesn't harm you. Your contribution is still perfectly valid.
Yeah, yours is valid. Yeah, no, I agree. I'm not seeing the value here.
This adds nothing, in my opinion.
Yeah.
Okay. It also costs very little. I see this more as assertions, things you know that should pass, and should they not pass, you're very happy that your application crashed instead of proceeding.
Yeah, I guess I brought them up just because when when the code gets audited, they might ask, why is there a difference between what's implemented and what the specs specify?
Okay.
But from reading it, is it also correct to say that before adding entropy, the contributor validates the SRS as well?
In what sense? We do subgroup checks.
Subgroup checks.
Yes.
I think was this benchmark? Because for me on the CLI, it's like taking quite a long time to validate all of it.
Is that using the crypto lib?
Yeah, I tried to basically use the same lib as the sequencer. So
Gotcha.
I just did .add entropy.
Yes, the subgroup check is about half the time consumed. It uses the endomorphism optimization, so it's decently efficient. I think BLST is a bit faster here. So when we have the working BLST backend, that might be preferred by clients, although we haven't done a proper benchmark yet in a multi-threaded WASM environment.
Oh no, I'm implementing CLI. Did you have any numbers for CLI? Because maybe my numbers are just off.
It should be in the order of 1 or 2 seconds.
Okay, then maybe something's off with my setup.
What are you experiencing? Because you seem to not be happy with the timing here, Kev. What numbers are you seeing?
I haven't sort of benchmarked specific numbers, but they were like noticeable. I could say like 5, maybe 7 seconds. So I think maybe something's off on my setup. All I do
For
is
all the contributions running natively.
Yeah, exactly.
Okay.
I just called this .add entropy method.
Yeah, that's longer than expected.
Yes, I need to debug what's happening there.
Hardware difference?
Yeah, could be actually. I'm running an Intel Mac 8-core Intel i9. Yeah, I need to debug what's happening there. That's strange.
Did you get substantially better performance with the with your own powers of tau lib?
Yeah, but I wasn't doing any subgroup checks up front.
Okay, no, those are expensive. That could explain the difference.
But without the subgroup checks, I was getting like maybe 1 or 2 seconds. I was expecting maybe like 3 seconds maybe with the subgroup checks if there's some optimization being applied, but I haven't looked deep enough to say anything else. But yeah.
Can I ask one more question about the sanity checks? So another one I thought would be useful is checking that all the pub keys of the individual contributions are distinct, which I don't think is currently part of the spec.
Right. I think I brought this up as well. And I think me and Dankrat said we was on Telegram and then it was agreed to not do this.
Okay.
Because it's just another edge case.
Sorry, Remco, your audio cut out. What was the last word you're checking for public keys?
Oh, checking that the pub keys are distinct. To just catch implementers that use the same tau point in each sub-ceremony, which seems like a obvious front-end mistake. And catching that might help build better front ends.
Yeah, so this was a discussion we had earlier. It was less in the context of front-end mistakes, but more on doing it like maliciously. And then it was argued that that's no different from just leaking your secret. And also there are like more complicated ways such that like combining multiple contributions could add up to being the same for one contribution, et cetera, But as a way of catching people, this might be something worth adding to the sequencer, as you're saying, hardening front ends.
Oh wait, Carl, I think we did say to not put it in.
Yes, agreed to not put it in.
Yeah, okay.
But I'm saying like as a way of hardening front ends, I could see the argument for it.
Maybe we can leave these enabled for the test version while people are developing, and then just remove them for the production version or for the audit.
Yeah, that makes sense. Just to make sure implementations aren't accidentally not being compliant. Yeah.
I mean, if we just specify a particular error message on that, like that gets returned there, then we can just include it in the specs and make it canonical too. That doesn't seem like an extreme thing to do.
Actually, Remco, could you clarify? You're checking for distinct public keys in a certain contribution and not in sort of the whole of the transcript, right?
Honestly, my approach here has been values need to be distinct unless I can come up with an argument why they shouldn't. So like all G2 points in the whole ceremony and transcript file need to be distinct unless the demands otherwise. That's kind of my approach towards these sanity checks. It's basically like taking it from the other direction. But
Right.
yeah, in this particular case, so it catches a number of things, like for example, the roots of unity, or like cosets thereof, but also sorry, no, cosets don't work anyway. But also contributing the same tau value in all 4 contributions, which to me seems like a common, like a plausible mistake a front end could do, or having an algebraic relationship somehow between them.
Right. I guess it's sort of hard to catch all of the edge cases. You can sort of do like what if. For the transcript, I don't know. I think that would probably be something we should skip, just because that's it grows linearly with the number of contributions. But for a particular contribution, I wouldn't see a reason why not to check.
Yeah, I think, like, again, I don't think, Remco, I agree, it makes sense at some level and we should see uniqueness here, but it's sort of hard to argue for this as being good standard behavior if it's not in the specs, and it seems a bit weird to specify.
Okay.
Yeah,
Yeah, I can just jump in. I think that generally, given we have a high profile demo in a couple weeks, I'd rather leave any other changes out for now and just get to the simplest working interface with sequencer that we can. And then I think post DevCon, we should have like a week or two just to tighten everything up and get it ready for the public reveal. And then maybe we can add anything else at that point. But for now, I think we should probably limit any other last mile things, though it is appreciated, Remco.
Sure. Now it can be disabled. I can see 2 ways forward here. So definitely disable in production. I can feature flag it in Rust and just have the code be disabled for the production version. Or do you prefer to have it actually physically removed, just so it's obvious for auditors or whatever?
I think probably removed, just less code, if it's not going to be used in production. Unless someone else thinks I should keep it.
yeah, I'm on the remove train.
Okay.
Yeah, sorry, back to what Trent said. So back on this double ETH sign-in thing, that's not going to be included in the demo, is that correct? I haven't actually implemented it in the CLI or looked into implementing it.
The double signing thing, or the
Yeah.
ETH sign?
The double signing, so you
Oh,
sign,
sorry. Yeah, you mean the where you sign your contribution through with the Ethereum
yeah.
address? Okay.
exactly, and then you sign the Ethereum address with your well, one of your tiles.
I mean, I guess this is up to everyone here implementing whether something they think they can do. I have the specs at 99% complete. I'll put them out by end of today. Basically, on the one side, it's a EIP 712 signature, shout out Remco, of the the 4 public keys that you're using, and the other way around are just a BLS signature of your identity, which is just either ETH appended to your name or GitHub appended to your GitHub address. It's I've got some argumentation as to why we only basically, there's only a double signature for the ETH stuff, and for GitHub, it doesn't really matter. So in terms of implementation, it's just being able to sign and verify ETH signatures, plus the BLS stuff. The BLS signatures should already be in the BLS libraries people are using. The one complexity here being for the sequencer, whether we can find a decent hash to curve implementation for Arcworks. Either just copying hash to curve out of Blast or something like that, or using one of these other implementations, particularly if it's running in parallel, that seems okay. But that becomes a bit more complicated then for the WASM blob. What are we doing for hash to curve there? And then the other side is the ECDSA signatures, but most Web3 APIs / JSON APIs should offer signed type data by now. The exception here being Web3.js. But I see that the ZK party front end is using ethers, so I think we should be all right on that front. So I guess I open this for comments to the floor.
Right, but for DevCon, it seems like there's probably not enough time to include this double signing. Like it'd probably be a bit of a stretch to get everything done with the double signing.
What needs to be done?
Doesn't it need to be implemented in the sequencer and also the client, the front end? I don't think Nicholas has started on this.
I think the sequencer and we move really fast. That should not be a concern.
So on the sequencer side, assuming you can get around the hash to curve thing, and you guys are doing the WASM stuff as well, so the hash to curve things on your side there too. The changes should just be calling like 2 extra API calls. That's fairly simple. On the, I guess there's more effort on the front end side. Again, it's 2 API calls, so that's relatively simple. It's, I guess, just incorporating it into the user flow as one extra step. But the logic is very simple here.
If I am not wrong, Charlie is trying to implement that, but we were considering that new call. Was that the question? Sorry.
Yeah, kind of just like what's if is there something you think that could be done in time? I guess you don't know the specs, so it's hard to see, but assuming it's like 3 lines of code or 5 lines of code in terms of like spec logic, is there something that we could see done by DevCon? Because I think it would be really nice.
I think we can do it on, okay, so regarding the front end, we have all the entropy input interaction that Charlie is doing a really nice animation work. I already have the contribution, like I am using the Rust code, using a wrapper, so if anything changes from the original code, I can like simply reuse it, right? And on the integration part, it's almost finished. I am just uploading the contribution and trying to check that everything went smoothly, right? So I think we can do it. Yeah, we have 2 weeks for DevCon, right?
Yes.
Yeah, 2 weeks, and I'm happy to lend a hand making sure that this is easy to do for everyone on this particular implementation thing.
Okay.
So I think the question would be what we have to do with this information and how is it going to be handled? If it's just some JSON that we download and suggest the user keep it for future reference, that's not a big deal.
So it's not even that. Basically what it is you take either the user's GitHub handle or the Ethereum address, feed into a function which gives you the byte encoding of that, like the standardized byte encoding, and then call a function that requests a signature from the user's wallet, which exists in Ethers.
Yep.
Yeah, and then that gets added basically into the contribution file. Yeah.
Okay. Gotcha.
So the work here is more just that it's an extra step that's sort of like after entropy generation, but before you start before you start pinging the coordinator to try contribute, that you need to get an extra ECDSA signature from the user. An Ethereum signature from the user.
Okay. Any other comments on this double signing?
I think we're good.
I'll push the specs probably two or so hours after this call, and we can have a discussion. I'm happy to help run people through it, see whatever wherever the pain points are, that kind of thing, and hopefully we can make a final call by the end of today. But then I'm going to operate under the assumption that this is not too difficult to implement, and therefore we can do it.
Sounds good.
Sounds good to me as well. Thank you.
Do any of the, I mean, we sort of segued into it naturally, but anybody working on the interface want to bring up question, comments, or anything that's come up in the work that they've done so far? So that's Charlie, Nicholas, Jeff, Takamichi. Now's the time if you guys want to bring anything up.
Oh yeah, so Takamichi's been working on implementing design as design changes come through. Nick has been working on the WASM stuff, as he mentioned. Question about the WASM: if we end up with BLST version, should we be looking to use that, or at the moment we're implementing KEZ code, and when we do include the subgroup checks, it does add quite a bit to the time. So should we, and we haven't got a good feeling for how that's going to pan out at the moment. We haven't done all the checks to see if the multi-threading is working properly and everything, but should we be looking, are we happy sticking with that, or should we look to the BLST?
So the check should be done after the contribution is sent off. So the timing for it shouldn't necessarily be counted. For the BLST, it's possible to just add it as a dependency to the Rust code just for the hash to curve part. So it's not too bad to just include it, that part in.
What's the advantage of doing the subgroup check after contribution? Like, why should it happen after?
Yeah, Carl.
Yeah, the argument here is it's basically optimistic contribution, so that in terms of the queue processing speed, it doesn't get added, as in you already upload the file once you've contributed without having done the subgroup checks. And because the sequencer is signing everything, you can shout about it after the fact with signed messages from the sequencer if they sent you something where the subgroup checks don't pass.
So would you then be checking the the initial values you received, or the ones where you added tau?
I mean, if you generated your randomness correctly, then it shouldn't matter.
Okay.
It's it feels like a slightly weird thing to do, but because because we're trusting the sequencer not to try screw with everyone, and B, if you do manage to pick up something here, that means that something dramatic has gone wrong, and we have a authenticated way of proving this happened with the signature from the sequencer, then that seems, yeah, this was deemed acceptable.
Makes sense. Yeah, I'm just wondering if adding tau by itself doesn't force the points out of the subgroup.
Does it?
I don't know.
I don't think
deep
so.
enough in elliptic curve math to have the answer here.
Right,
Sorry, what is the question?
Like if you multiply a point by some random number and this point has is a part of a low order subgroup, or is a low order subgroup component mixed in, does it still have that low order subgroup component in there? And my answer is
No.
yes. You think no?
No.
Wait, I thought that if it has the low order subgroup and then you multiply it by a point, that's a multiple of the low order subgroup.
Sorry, what are we doing? Are we talking about, so omega is a low order field element, right? And we have omega times g. And now we take a random number r and compute r times omega times g. Is that what we're talking about?
That was my
Yeah, then that
assumption.
is definitely not in a low order subgroup.
Right, it will just get rid of it since.
I mean, otherwise, yeah. I mean, G itself is a low order subgroup. It's 1, right? That's a low order subgroup of order 1.
G.
Yes, the generator.
No, it's not.
Yeah, it is. One as a field element is a low order subgroup.
I thought that was a prime order subgroup.
Oh, you're talking about the additive group. I'm talking about the multiplicative group.
Okay.
So what? Okay, so you're talking about a different. Well, then there is no low order subgroup. Like the additively, there is no low order subgroup because we're working in a prime field.
Right. I think the assumption was that you added a low order component to some prime order element.
Yeah, basically you're mixing in something from outside the
so you're talking about
field.
the point that is not in G1.
Yes.
All right. Yes.
But is on the curve.
Well, yes. Yeah. So okay, right. Well,
yeah.
I mean that depends on your definition of the curve. I mean, it's
sure.
not on G1.
It's not on G1. I agree with that.
Solution to the elliptic curve equations. Yes.
Yes.
Okay. Right. Yeah.
So here, if you mix in a random point, you're still going to get basically this. The output is going to be still a composite of this low order component and the field component.
Yeah. You can multiply by the cofactor to get rid of that.
Yeah. No, that's like.
But yeah.
Yeah.
As long as it doesn't need to be the cofactor, it just needs to be a multiple of whatever the order, the low order is.
Right, but you don't know
Yes.
what the low order is.
Okay. So
If it's like, I mean, assuming that this is controlled by the attacker, then you just have to
right.
use the cofactor. Oh, sorry, is this about the sequencer trying to find out some bits of your entropy
Yeah,
by
so
sending
No.
you these?
Okay, I'm saying yes, apparently Remco is saying no. So if Remco is saying no, then what's the?
I'm saying this is about whether it changes anything if we move the subgroup check on the contributor side to after adding the new tau value.
But
whether that
the
would
reason,
whether there are scenarios whether it would give a different outcome for the subgroup check.
oh, okay, yeah, sure.
Oh, I see. Well, I mean, what I would do is I would still check it on the inputs, but still do it after the contribution. And if the sequencer has cheated, like I'm assuming is the message signed of like the.
Yeah, they're signed. That's the whole point. That's the reason.
So basically,
yeah.
you have proof that the sequencer cheated.
Yeah,
if
yeah.
you fail the subgroup checks.
The question is this still acceptable if we do it after you've multiplied? I guess the other reason it's important is to be able to prove to this to other people. That the reason to do it before is to prove it to other people. You need the message that the sequencer sent to you because that's what's signed. The sequencer didn't send it to you with your entropy mixed in, and presumably you've deleted your entropy at this point.
Yeah, I would, but what's the reason for doing it with your contribution rather than the input?
Just 2 files to keep track of.
Okay. But I mean, I was saying like we're running out of storage here or what? Like, I mean, like just store it and then do the check. I mean, that seems trivial, right?
I agree with you.
Yeah, I would, I mean, I would just do it on the original. First, it's signed, so we need to do it on the original. And second, there's a small chance that your contribution might erase the, like, for example, your contribution could be a multiple of 32 or something, and that, yeah. So it's possible that you are in the subgroup, that you cancel the subgroup. Well, sorry, subgroup, low order part.
I don't think the messages are all signed, only the receipt, as far as I know. We also removed the signing on the ID token that we used to send. It was automatically signed by JWT, but that's been removed.
But wait, what was wasn't the sequencer doing ETH signing of messages, or have I misunderstood things? Yeah.
Yes, we can ETH sign messages, and it's trivial to add a couple more signatures on responses if you need them.
Okay.
Right. No, I'm saying it's not done right now.
Okay. In that case, can we add a signature to the JSON message basically that gets sent, the contribution file?
Yep.
Yeah.
Great.
That might change the API, of course, because now we have a signature field to add.
Right. Yeah, as I said, we also removed the signature on the ID token that gets issued. I don't know if it's a massive problem with double sign being implemented, but I haven't checked completely.
What's the attack vector, or what's the scenario you're imagining here?
So usually once you do the OAuth, the sequencer gets back your GitHub ID and then he sends it back to the client with a couple other information. And that used to be signed, whereas now that's not signed. So the sequencer could just say, like, could like collude with 2 people and say you're Vitalik or something. And then, yeah, that's mainly the attack vector. You can just basically say, I didn't send you the GitHub ID Vitalik. But
wait, does OAuth allow this?
No, it's not OAuth. It was just that the ID token was signed. But I'm thinking through the attack vector, and I think that because they send a receipt, it doesn't matter because they have to sign the receipt at the end.
I mean,
So-
I can always lie about having authenticated a user without authenticating them, unless I'm doing some action that, like, unless I'm posting something on their GitHub account, I can always say that I authenticated you. I don't know how would you defend against it. It's just an ID, right? Like it's a string that I can make up always.
You can always lie, but before it was signed is what I was saying.
So I'm
So-
signing my lies. What's the difference?
Well, if you're signing your lies, I could say that you lied. If you're just not signing your lies, then you could say it wasn't me who sent it to you. But like back to the original, I think it doesn't matter because the receipts are signed. So once you contribute, I sign your receipt, which includes the ID token. So it doesn't matter actually.
Still on Martian's side here, I'm not seeing like what the value is. That the ID is a random string, so there's no way of like authenticating it after the fact, or so not authenticating, verifying it after the fact.
You're not offensive. You're basically, it's basically the sequence that's saying that this is the GitHub ID of Kev, and this is the one that he authenticated with.
Yes, but I can always do that. Like I don't think you can defend against it, except you can look through the transcript and see if there is an entry that you didn't create.
So this gets into a bit of like my argument for the whole double signing thing, and I was arguing against doing it, or I argue against doing it for GitHub. Basically, your identity, you just trust the coordinator not to have lied with your identity there. And if they do, we can shout about it.
Right, but in the GitHub case still, because we signed the receipts, which include the ID token, you can at least hold the sequencer accountable.
Yeah, sure. This is an additional way of holding them accountable, I guess.
Yeah, so that's why that's why you don't need to sign the original ID token, because it's signed in the receipt.
I mean, yeah, that, and like if you are signing like if you BLS sign your identity, your GitHub ID, then that's tied to your address anyway, right? Like when you put it out in the transcript, it'll be obvious.
Right.
But yeah, as you're saying, it's in the receipt as well. It's like in several places. Yeah, I'm not seeing an attack vector.
Right.
Yeah. Like at the end of the day, we're only going to know this once the full transcript is out.
Right.
Or whatever incremental transcripts we output before then.
Yeah. Yeah, I did have a few comments on some sequencer stuff, but I think we can probably do it async since they don't affect most people. And it was mostly UI, basically integrating the front end with the sequencer, just some endpoints that would disambiguate sort of what the front end gets.
Okay, yeah, if you want to write that up for the interface people to check on, that'd be good. Chiali, do you want to do a quick demo?
I think it will be Takamichi, sorry. I'm
Oh,
just
Takamichi, okay.
Yeah, thank you.
Yeah, up to you, Takamichi. On my side, I've been working on sort of some adjustments to the interface, so it's just has a little bit of a different graphic style, and so this won't show that. So it's on me to get that done ASAP and properly transferred over to the interface team. But Takamichi, if you want to do a demo now, that'd be fine. Or any other interface comments if you'd like to bring them up now.
Yeah, can you hear me?
Yes.
Oh, okay, so I can show some quick demo now. And actually it's not complete yet, so but for now it can sign in and contribute to the sequencer, calculating the contribution using the WASM web worker. So for that part, I can show the quick demo right now.
Sure. Yeah.
Okay. Now let me share. Oops. Can you allow to share my screen? Okay. Oops. No.
Oh, does it still not allow you to, or maybe?
No. It asked me to turn on my video.
How about that? I made you co-host.
Yes. All right. So here is the front end of the ceremony trusted setup. Yep. Here is a landing page, and it has some descriptions of the trusted setup, and there's a FAQ section here and some footer. Yep. And it's so here is the sign in page, and once you click the sign in with Ethereum, can you see the pop-up of the sign in
No.
with Ethereum? No? I'm okay. Maybe I need to share the whole screen.
Yeah.
Yeah, okay. Right. Can you see the
Yes.
pop-up? Okay, so once you just click the sign in with the Ethereum button, this pop-up will show, and you can proceed by signing the OAuth provider. And then the entropy input page shows, and as you can see, here's the progress bar that they capture the mouse movement like this. And also here's some random input. And once the progress are complete, you can enter to the lobby. And now.
So your screen is still not showing up for me. It still says it has started screen sharing, but it's not showing up.
Oh,
really?
I can see it. It might be you.
Oh,
Duncan.
now I can see it.
Okay, so now it automatically polling the try contribution API endpoint, and once it get accepted, it automatically start calculating the contribution backend. I mean in the WASM web worker. Then this is gonna take a while, so maybe we can I can stop here. But yeah, after this finished and posting to the sequencer endpoint, yeah, the contribution is done.
Great.
I have a question. Was the E623 in the top right-hand side the session ID?
Yes, yeah, I need to fetch the user data from the OAuth provider, but yeah, for now for the yes. So
Yeah, you should get it back from the sequencer.
yeah, like the authentication endpoint, right?
They give you back an ID token, which includes the GitHub. Like there's something called a nickname for Ethereum. It's the Ethereum address, and for GitHub, it's the GitHub user ID.
Oh, okay.
Yeah. Yeah. Thanks for sharing. Thank you.
Great. Yeah. Echoing that, it's nice to see. Feels like 90%. We're almost there, which is great given how close we are. Are there any big blockers or challenges you're having implementing stuff that haven't been brought up yet?
I think there's not that big blocker for now. Yeah, but I needed to modify some sequencer code, like adding some coarse layer to the axiom, or the disable the rate limiting the body size of the API or something like that. But I think it's not that problem, and yeah, everything is going fine, I think.
Okay, great. If you need help or you're falling behind, just say it sooner rather than later so that we can find some more people to help you, or anybody on the interface team. Yeah.
Yeah, thank you.
Takamichi, could you ping me about the rate limit disabling that you did? I saw that you used an Ethereum address, which looked like it was new. So I'm guessing you also disabled the validation checks.
Okay.
Is that correct? Because I had to disable the validation checks for new accounts. The error that was coming up wasn't very helpful.
Actually, what I meant was the body size limit of the post request. So it's not about the limiting the Ethereum from the same Ethereum address.
Yeah, sorry, I brought up two issues and just skipped over it. So for the first one, the rate limit, could you ping me about that?
Okay.
And then for the Ethereum address, I think you used a new one, which means that you disabled the Ethereum validation, right? In the sequencer code?
No, for the sequencer, I am resetting the database every time I try. So
okay, all right, thank you.
Also, it would be great if you could open GitHub issues or write on Telegram or in any other way. Let us know that there are problems you are facing with the sequencer. Because my assumption was nobody is actually testing this. Now it turns out that people are testing it and just not letting us know about the issues they encounter, which is not optimal.
Okay, I will. Thank you.
Yeah, sorry about that. I was sort of collecting them. They're mostly UI issues. Like if you use the new Ethereum address, when you call the ETH get transaction, it gives an error. And then that error propagates up to like could not fetch user data, which might not be beneficial for the front end.
Yeah, I agree. So yeah, open a GitHub issue or a pull request. But if you actually fixed it, would be great to have a working list of the issues you guys find.
Mm-hmm.
All right, we are at time. Really quickly, given how close we are to DEF CON, I think it might make sense to have another call next week, just optional. I mean, these are all optional, but if people want to show up, and hopefully we'll have a demo by then, or we can do the same type of demo next week, same time. And that would be good just to continue ironing out any issues that come up. I'll go first. Over the next few days, really, I'm going to be really pushing hard on any of the interface updates to get them to the people working on that as soon as possible so they can make the modifications. Anybody else have some pressing concerns other than like getting stuff done in preparation for this demo? If anybody wants to say what they're going to be working on, now would be the time.
So I'm pretty sure I haven't met most of you guys, but I did an implementation of both the sequencer and a client for ETH Prague. And I would like to do at least the client part for the real ceremony as well. I've been just trying to go through the specs, the open API ones, and there's a lot of stuff missing or kind of weird in it. Are you going to update those, or should I just look into the implementation and see what the others are using?
It should be there, Marius. There was a fairly big change where we switched from a queue to a lobby. Might be one of the larger things, which makes it look like some of the endpoints got deleted. It was quite a simplification.
Yeah, no, that's fine. It's just that some endpoints,
like data types.
yeah, like the data types are not really specified, or some endpoints lack the data types that I would suspect. So, for example, the ceremony status is just not specified.
Yes, that is correct. I think this is also a bit because there was debate as to what should be included in that. But yeah, I don't know if the sequencer people have a comment on that.
I would just say once again, write it in a GitHub issue or in either the specs repo or in the sequencer repo, and then we can, if you find any discrepancy between the documentation and the actual behavior, we will reconcile it by changing one of them.
Oh, okay.
It would just be good to have a list of what doesn't work for you.
Yes, I don't have a link to the sequencer issue. Can you put that in chat? To the sequencer GitHub.
I think this is something that needs to be added to the specs, the open API.
Yeah.
Added the status, but I didn't add it into the specs. So the specs needs to be modified.
Yeah, no, you're correct here, Marius. That's agreed. In general, there's this other repo which has got links to everything else you should need to find, Marius. But the two repos you have now should be sufficient.
That's a really good thing. Thank you.
Marius, do you have the work you've done at ETH Prague public somewhere? And can you share links?
Yes. I'll put a link in chat.
Thank you. Awesome.
It was the Towers of Power repo written in Go.
Gotcha.
I don't know if you've seen that, Remco. This was, yeah.
I think I did actually, yeah.
Mm-hmm.
All right, so it sounds like, yeah, there's still some work to be done. Like I said, we'll plan to meet again next week, even though it's usually every 2 weeks. We'll meet again next week, and everybody will probably continue with the regular async comms over the next few days in the Discord, Telegram, etc. I'm pretty confident this is coming together, and we do have a slot. So just for context, the DevCon slot is on the main stage, the opening ceremonies. There are 3 speakers and we are just before Vitalik. So this is going to be very high profile, very visible, and hopefully get a lot of people exposed to what we've been working on for the past few months. And, you know, it'll be nice to have the work visible by so many people in the Ethereum community on such a high profile place. So great work, everybody, so far. We are at the last stretch before the public sees this, and then you know, it's going to be really exciting. I'm pretty stoked. So I was talking with Carl, and I think if we can make it happen, if you're in Bogota while we're doing this presentation, we'd be happy to have you on the stage. Logistic issues, assuming we can work it out, but it would be really cool to have people on stage that worked on this. So that's where I'll leave it. We're a couple minutes over. Thanks everybody for sticking around, and we'll see you next week. All right, bye.
Bye.
Bye-bye.
Bye.
Bye.
Oh.